Assalamualaikum students. Students, today we are starting with Ionic Equilibria. This is the first lecture of Ionic Equilibria, and equilibrium is a property of reversible reaction. The reaction that can proceed in both forward and backward direction. Such reaction reach dynamic equilibrium. This is the continuation of AS. Characteristic of equilibrium, it is dynamic, moving forward and backward continuously, right? The rate of the forward and the reverse are at the same rate, they are equal. The concentration of reactant and product, their concentration become constant. And it is in a closed system. Keep in mind, nothing can leave and into the system, right? Now, equilibrium constant. KCKP, we have done in AS. And now K2, KA, KW, KSP, KPC, K stability that you study in transition element, these are equilibrium constants in A2. The basic concept of all the equilibrium constant are same, only the type of the change differs. Like if acid ionizes, Ka, if water ionizes, Kw, if salt dissolves, Ksp, if the same substance into different solvent, Kpc partitioning. These are all equilibrium constant, and all equilibrium constant depends only on temperature. We know that equilibrium constant for endothermic will increase with increase in temperature. For exothermic, the Kc, Kp, Kw, K, everything, if it is exothermic, it will decrease. Endothermic, the equilibrium constant will increase. Now we will start with acids. We know Lowry-Bronsted acids and bases. What is Lowry-Bronsted acid? Acid donate proton and base accept proton. Right? There are many questions in the recent papers in P4, and which they talk about the conjugate acid and bases in A2. But you know how they make the question? They say, I'm going to use a separate sheet for explanation, like the notes are available on my website, right? Chemistry by Zeenat. The notes are available over there. The topical past papers are available on Chemistry by Zeenat website. And don't forget to like, subscribe, and share my channel. And now coming to Lowry-Bronsted acid and bases. This is H2SO4. If you put H2SO4 in water, how many conjugate acid-base pair are formed? You know how much? 3. How? Look. When you put H2SO4 in water, it will give H plus to water, making H3O plus and HSO4 negative. In the next step, the HSO4 negative will give H plus to another water, making what? H3O plus and SO4 di-negative. So one thing is clear, like the H2SO4 is giving H plus stepwise. First H plus, making HSO4, second H plus, making SO4. This is acid. This is its conjugate base. Why? The acid and the conjugate base differ by 1 H plus. So H2SO4 and HSO4 negative, conjugate acid base. These two differ by how many H plus? 1 H plus. This is acid. This is the conjugate base, second pair. This is acid and water is what? Conjugate base. So how many pairs you can see? HSO4 with HSO4 negative, HSO4 negative, and SO4 di-negative, H3O plus and H2O. These are bases, 1H plus less. These are acids. Conjugate acid-base pair differ by 1H plus from each other, right? So same is the case with, like, suppose if you put ammonia in water, how many acid-base pair? 2. How? Ammonium and OH negative. Ammonium is acid, ammonia is base, 1H less. Water is acid, OH negative is a base, 1H less than the acid. Now, after conjugate acid base, your next topic is pH. You know what is pH? What is the meaning of the word pH? The P means negative log to the base 10. Right? If you want to write Lg, you know how you're supposed to write? Like, suppose you don't want to write 10, then skip this O. This becomes what? Negative Lg. You know, negative log to the base 10 is P, this P. So what is pH? You know, pH is what? Negative log of the concentration of H plus. Negative log of the concentration of H plus. You know, pH is not negative log of acid. No. No. It is the negative log of the concentration of H plus. You know, what is the meaning of this 10? The 10 means if pH changes by 1, H plus will change, concentration will change 10 times. If there is a change in the pH of 1, the H plus will change by 10 times its concentration. So it's counting in tens, kind of. Now look, pH is what? Negative log of the concentration of H plus. If I know H plus, what am I supposed to do? I will take negative log of H plus, and that is what? pH. If I know pH, how can I get H plus? Just 10 power minus pH. Look, pH is negative log of H plus, and H plus is 10 power minus pH. From where in any solution H plus is coming? From where H plus is coming? From acid. The acid in water will provide H plus. If you know the concentration of H plus, can you find the pH? Of course. There are 2 types of acids. Acids are of 2 types. Strong acid and weak acid. Strong acid ionize completely. So, if I have a strong acid, it will ionize completely, making H plus. If I know the concentration of H plus, I can take the negative log of that H plus, and it becomes what? pH. It becomes what? pH. For example, I have HCl, I have HNO3, I have H2SO4. And they are each 0.1 mole per DMQ, 0.1 mole, 0.1 mole. Now, H plus Cl negative, H plus nitrate, H plus, how many times? 2 times. And sulfate. 0.1, it's 0.1, 1:1, 1:1, but since 1:2, it is what? 0.2. If I take the negative log of this, pH is what? Negative log of 0.1. It is what? Negative log of, again, 0.1, it's the same. But pH is what? Negative log of 0.2. Now, where the H plus is more, this, what is the pH? Here the pH is 1, here the pH is 1, but here the pH is 0.67 if I'm not wrong. Right? Now, listen. If the H plus is less, the pH is more. If the H plus is more, the pH is less. Stronger acids have lower pH. This we have done in O level in AS. But now we are going toward the clear concept. If the H plus is more, the pH is low. The pH is low. Right? So, if you take the negative log of a large value, it becomes what? Small. More H plus, lower pH. It's mathematics, not chemistry. Chemistry is what? More H plus, more acidity kind of. The pH is lower because we take the negative log. Now, suppose if I'm having aqueous solution of H2SO4 and its pH is suppose 1.5. How can I get the concentration of sulfuric acid? You know what I'm supposed to do? From H plus, I will get what? From pH, I will get what? H plus. 10 power minus pH. So 10 power minus 1.5, I will get H plus. Now, I know that H2SO4 ionizes, produce 2H plus and 1 sulfate. For every 2, there is 1 acid that ionizes. For 10 power minus 1.5, can you find the concentration of sulfuric acid? Yes. So coming to the notes, explanation of Lowry-Brown state, then pH is negative log of H plus, negative log of H, P is this. If H plus you want to find out, 10 power minus pH. In any aqueous solution, the H plus is coming from acid. Acid, proton donor in aqueous solution, strong acid and weak acid, 2 types. Strong acid ionized completely. The square bracket says, it shows the concentration. Every strong acid ionized complete, making H plus, take the negative log, you get pH. But if you know pH, can you get H plus? If you know H plus, can you get the concentration of strong acid? And I've explained this to you, right? If the H plus is more, the pH is low. If the H plus is less, the pH is more. Negative log of large value result in what? Small value. And then I did this, that if you know pH, you can get the concentration of what? H2SO4. But if your weak acid is, if your acid is weak, it's not going to ionize completely. Like you don't know that out of 1,000, how much are H plus, right? So in my next lecture, I'm going to explain weak acids, right? In the next, you will get weak acids. And I will do some questions with you people like this. See you in the next lecture. Bye.